All right, Unit 8, all about perimeters, areas. So 8.1, like I said, is rectangles and squares. I think the next one might be like triangles and parallelograms. Then we might have trapezoids. But when it gets a little tricky is when we get like pentagons, hexagons, octagons. You got to find the area because the angles can be different. So there'll be a few ways to show you. There'll be some formulas that you can use. So we'll get to those. It gets a little trickier, but the first three sections this week should be pretty easy ones because you already know rectangles, squares, and parallelograms and triangles and stuff. Should be easy, but there will be some thought-provoking questions that you see on the homework and stuff. They're not just all simple, basic, find the area of this rectangle, because you know how to do that already. You want to be able to apply the formulas that you have to some of the problems that you'll see. So that's important. All right, rectangle, squares, the angle or area basics it's the measure of the interior region. So area is always the inside amount. And we always measure area in square units, so little squares. It's a two-dimensional measurement. It measures length and width. So it's always got two dimensions, and you can see right here, this is a little 2. It's unit squared. So you're always going to be using square units in this. So if you were looking at this rectangle, it would be 14 across, and it would be not 7 units up and down.
It's 15.
Is it 15? I think it's 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14 across. Scaring me there a little bit. And so 14 times 7 would be 98 square units. So you could actually count inside all of those little squares, and you would end up with 98 of those little squares. Just by coincidence, the floor that you see down here, those are all square feet. Each one of those little squares is a foot by a foot. So the area of this room, we could actually count all the tiles and get the area of the room. All right. All right, so that would be the first part. There's nothing else on this slide. Okay, here's example 1. Tomas is estimating the cost of replacing the carpet in his living and dining rooms. He measures the rooms and writes the dimensions on the sketch. How many square feet of carpet is needed? That's 1. And then if the carpet Tomas chooses is $2.49 a square foot, how much will the carpet cost? That's question number 2. That should have a question mark there, sorry. So we've got 2 questions that we need to look at. We need to look at how much carpet is he going to need, and then how much would it cost altogether. So now this is not a shape where you would actually have a formula for it. So you're going to need to break it into shapes that you do have formulas for. In this case, you're going to break it into a square and a rectangle. So the first thing we would probably do is we'd look at the square dining room, because I noticed that I see a 10 and a 10 there. So the first thing I'd probably do is take a line here and take a line like a dotted line here and make a line straight up so that you can see the square dining room, and it's got a 10 by 10 dimensions to it. So the area here, which is inside the picture, I would put 10 squared, so my area would be 100. And I might circle that inside of that box or inside of that shape so I know that that's the area just of that shape, because I want to put all of them together. So the square dining room has an area of 100. The living room. Anybody have any idea what this length is over here? 24, because you got 14 here, and then you got 10 right here. So we've got 24 feet there. And so your rectangular living room has an area of 12 by 24, which is 288. So inside the picture, I might put A equals 12 times 24, and then 288. And then circle that because those are the areas of each shape. So I've got an area for each shape. So then you're going to put them together because you need your total area. You need to find out how much carpet is he going to need. So you know that in the dining room he's going to need 100 square feet of carpet. in the living room, he's going to need 288 square feet of carpet. So altogether, he's going to need 388 square feet of carpet. Got the 100 plus the 288. So 388 square feet of carpet, and each one of those square feet is going to cost him $2.49. He's got 388 of them, and each one is $2.49. So it's going to end up adding up quite a bit because carpet's not that cheap. $2.49 a square foot is an average amount for carpet. So he's going to need to multiply 388 times the 249, and it ends up costing him $966.12 for the cost of the carpet. Now, if you've ever learned about carpet, done carpet, then you probably know that he's not just going to write a check for $966.12, give it to the guy, and it's going to be done. There's a lot of other stuff involved. What are some of the other costs that he's going to have to incur? Okay, the installation cost. That would probably count all the nails and everything else. He'd probably have to do an installation cost. That's labor. That's all the other little things like the nails you said that you need. The what? The cushion or the padding that goes under the carpet. You don't just put the carpet directly on the floor. So there's more cost he's going to have to incur. The tax on both of those things. So he's going to end up paying probably closer to $2,000 for everything when he's done paying for that carpet. So he's got to put all that stuff into account. How much is this going to cost? This $966.12 is just the cost of the carpet. That's nothing else involved. That's only his carpet cost, and then you have to do tax and all this stuff. All right, example 2. Example 2, we've got a coordinate little graph example. Like we were kind of doing last unit, we were talking about coordinate geometry. And we want to find the perimeter and area of the figure with the given coordinates. Now these are going to be pretty easy ones because we're talking about rectangles and squares. So we should have some easy ways to do it. But let's go ahead and graph these 4 points. 4.5 comma 3. So over 4.5 and up 3. So probably right in this area. And then negative 5, 3. So it's right in this area right there. And then negative 5, negative 6.5. So it's going to be right in this area. Oh, I came out a big dot. And then 4.5, negative 6.5. So basically, when we draw in our shape, it's going to look like that. So what kind of a shape do we have? How do you know? You would have to prove it's a square, right? You'd have to say, I can show you without a shadow of a doubt that that's a square. The way you do that is by looking at, first off, the change in y. You remember that little triangle symbol means change in? So the change in y is our height. It'll tell us how tall it is. Now, if it's directly vertical like this, you could probably just count straight down. If it's not vertical, you may need to do the distance formula to find out what length that actually is using the distance formula. In this case, our change in y, we would start up here at 3. So we would start at 3, and we would subtract the negative 6.5, and it's going to have a 9.5 change. So y went down 9.5 units, or went up 9.5 units, depending on where you start. But regardless, it's 9.5 units long. That would be my y change. That's my vertical change. My x change is my horizontal change, the length in this case. The change in x is going to be how long it changes, how much the length changes. So again, we could start at -5 over here. So it's -5, and we're going to subtract the 4.5 because that's where it ends. And you would get -9.5. Is that a possible length of a square, -9.5? No. Do you notice these lines right here? Absolute values. These absolute value lines right here are telling you that it's got to be a positive length. So we would change this to 9.5. We put this in absolute value signs, and we get a positive 9.5 units. So now you've just proved it's a square because both sides are the same. And that means that the other two sides are also 9.5. They're all equal. So there is a proven square. So now you know the formulas for a square. Since it is a square, the perimeter has to be 9.5 times 4. So the figure is a square. And you take the 9.5 times it by 4 sides, you get 38 units. Now 38 is a linear measurement. It's a one-dimensional line around the shape, so it's not square units. Area is the two-dimensional, length and width that you need area for. But a linear length is just one line around the shape. You just go one line around the shape, and that would be your linear length, so it's just units, just 38 units around. Now the area is easier because it's the side squared. It's just 9.5 times 9.5. So area is 9.5 times 9.5, which is 90.25. 90.25. So that's your area of that square. That means if you counted all the little squares inside of that square, you'd have 90.25 of them. And where would the quarter one be? You see this little quarter right down here? That would be the quarter. Two of these makes one hole. So this is one hole, that's one hole, that's one hole, these two are one hole. This one would make one with this one down here, and then these two are, so on. But you'd still have that quarter one that would be by itself. So you'd have 90.25 squares inside of that shape. Yep, there is a 0.25 square. This is 1/4 of the square. Good move? Okay. Those are the two examples. The rest of them are just some practice ones. They're similar to tonight's, but I'm telling you, tonight's are a little more thought-provoking. They're going to make you draw a picture here and there. They're going to make you think about a few things. They're still going to deal with rectangles and squares, though. It's not going to deal with any other shape. So it shouldn't be too difficult for you to do. This first one, we need to break it into shapes that we know. So let's break it into a rectangle or two rectangles. Should I do a vertical or a horizontal line? Will it matter? No. You can decide. If you want vertical, then you would just go one straight down like this, and then you'd have two rectangles. Now I need to find the dimensions of each rectangle. So I know 8 is over here. Do I know this side down here? I don't know it, but I can figure it out, can't I? I've got a whole thing is 10. I got part of it 6. 4. So the other part has to be 4. So I'm going to put area equals 8 times 4. So in this case, my area is 32, and circle it, and we got one area done. We just need to find the areas of each part of the shape. This one is 6 times 3, because it's already given to us. So the area here is 18. So your total now you got to put them together. Total area is 32 plus 18. That's where you're going to get 50, and that's where you're going to put in the square centimeters. That's where you're going to put in the unit measurement at the end. It's 50 square centimeters. Now, a lot of students struggle with the shaded area part problem, where you got to find the shaded amount. You see something like this, and what do you think we're going to need to do here? How do we find the shade? Let's pretend like this is a grassy area, and this is my cement sidewalk around it. And I need to know how much concrete to get.
What do you want the area of squares?
Okay, so find the area of the big one. That gives me everything, right? If I find the area of the little one and I subtract that out, the only thing left over will be the shaded area. So that's going to be our plan. The plan is that we're going to take the big square and we're going to subtract the small square. And that's going to equal the shaded. Okay, so that's what the plan is. That's our plan of attack. That's why I wrote it down first. Now the big square is going to be 15 squared. The small square is going to be 10 squared. Y'all good with that? Because 15 squared, 15 times 15 is the whole thing. 10 times 10 would be this middle part. So 15 squared is 225. And 10 squared is 100. So 225 minus 100 would be 125. So 125 square feet would be the shaded area. That's how you get a shaded part when they're both squares. If it was a rectangle and a square, or two rectangles, just two do the same plan. The big one minus the small one gives you the shaded area, if there's an amount inside. Now the third one there is kind of a large one. We're going to need to make two lines. You can make two horizontals or you can make two verticals. It won't matter because you'll get the same answers either way. You want to do two verticals? We'll do two verticals. So one of them goes here and the other one would go here. And now you just need to find your area for each rectangle or square if it's a square. Let's start with the small one. Do we know the dimensions of the little one? We don't have this piece right here. Is it 4? 16 is the top. Minus 6 would be 10. Minus 6 more would be 4. You're right, this is 4. Okay, so this is area is 2 times 4. So my area is 8. So there's one piece done. Now the middle portion is a square. It's a 6 here, and this is 4 plus 2 more, so this is also 6. So your area is going to be 6 squared, because it's a square. So in this one, your area is 36. So I found my two areas, I put them inside their shapes. Always do that if possible, because you'll know what shape is what area. And then the last one is given to us, 6 and 12. So area is 6 times 12. Area is 72. So for the total, we need 72, plus we need a 36, plus we need an 8. 72 plus 8 is 80. 72 plus 8, if you did that first, you would get 80 with those two, and then 80 plus 36, you get 116, and that would be square centimeters. Okay, so that's just breaking it into 3 pieces, finding the area of each piece, adding them together. Now, it's a review problem from first semester. There's about 4 ways to solve this one.
45, 45, 90.
Okay, so law of sines, and is that a possibility?
No.
No, because why?
It's a right triangle.
Because it's a right triangle. You can't use law of sines if it's a right triangle. SOHCAHTOA, would that work?
Yes, it will.
That's one possibility. So let's list the possibilities, and we'll see which one you want to do the best. So one, we could do so, or toa. Okay, so that's one possibility. Give me another one.
45, 45, 90.
Okay, 45, 45, 90. We could try that one if we'd rather. So 45, 45, 90. That's another possibility.
Pythagorean theorem.
There's the last one was what? Pythagorean theorem. That would be the last possibility. Now, the reason I said there's like 4 possibilities is because with SOHCAHTOA, you could use sine or cosine in this problem. With 45, 45, 90, there's one formula that you'd have to use. Pythagorean theorem is one formula you'd have to use. So you got 3 choices. What would you choose? So you guys would use SOHCAHTOA. Anybody else want to use SOHCAHTOA? That's what you would do. Anybody want to use the 45, 45, 90? Okay, I have a couple that would do that. So the rest of you are Pythagorean theorem people?
You don't have, you don't have the pieces.
You do not have to be here, you sure? What kind of a triangle is it? It's a 45, 45. So if this one is the same as this one, then this leg is the same as that leg. You actually have both legs. So 9 radical 2 is there. So you got to decide what kind of a person you're going to be when you solve these, because you're going to see problems like this. You're going to have options, and you just got to find, okay, which way works for me? Which way do I understand? You have to know that if you understand SOHCAHTOA, then you're going to use this one, you're going to use adjacent, you're going to use hypotenuse, and you're going to do cosine of 45 equals the adjacent side 9 radical 2 over x, and you're going to solve for x. Okay, that's one possibility. You could do that if you like SOHCAHTOA. If you're a Pythagorean theorem person, then you got to do 9 radical 2 squared plus 9 radical 2 squared equals x squared. You just got to be careful with 9 radical 2 squared. Think about what 9 radical 2 times 9 radical 2 actually is. It's not 18. 9 radical 2 times another 9 radical 2. Not 18 radical 2.
18 radical 2 squared.
Let me write it like this. 9 radical 2 times 9 radical 2. What's 9 times 9?
81.
81. What's radical 2 times radical 2? 2. What's 81 times 2?
162.
That's how much 9 radical 2 squared is.
Oh.
So you got to put 162 plus another 162. You get 324. And when you square root both sides, you get 18. That's with Pythagorean theorem. You would get the same answer with the cosine here. You would multiply both sides by x. You would divide by the cosine of 45. And you would take 9 radical 2 divided by the cosine of 45 in your calculator. You're going to get x is 18 as well. Okay, you're going to get the same answer. What would the easiest way be? The one that you guys talked about right here. There is a formula that says the hypotenuse equals radical 2 times the leg. What's the leg in here? 9 radical 2. 9 radical 2 times radical 2. What's radical 2 times radical 2 again?
What?
2. And what's 9 times 2?
18.
Same answer. A lot faster. If you know that formula. You just have to know what works for you guys. Okay? There's all kinds of different problems that you could do with different scenarios, because the right triangles, you've got all kinds of options. You just need to know which one works for you so you can use that every time and get them right every time. Okay? All right, we've got 2 left, real quick. Draw the figure with the given vertices on an XY coordinate system. Find the perimeter and the area. So, 0, 0. Let's make a dot at 0, 0. 6 zeros over here. 6 and then 3.5. And 0 and 3.5. And it's just a practice one that we did before. So we're just going to draw in our rectangle in this case. And you should be able to, since it's horizontal and vertical, you should be able to just count across and get the lengths. Now, if it was turned a different direction, then you're going to need to use the distance formula to find the sides. So right now you can count across. This is 6. This is 3.5. Here's another 6. Here's another 3.5. How do I find the perimeter, since I need perimeter and area? Okay, so I've got 2 6s, don't I? Don't I have 2 6s that I need to add together? And don't I have 2 3.5s? So I've got 2 of each one. I need to add them all up. So I've got 2 6s, which would add up to 12. I got 2 3.5s, which would add up to 7. So my perimeter is 19, and that's just units. That's not square units. 19 is a linear measurement around it. And then the area we know is 6 times 3.5. Anybody want to venture a guess in your head at 6 times 3.5?
21.
Ooh, how'd you do it?
6 times 3.
6 times 3 is how much? And then 6 times a half? 3 more, so 18 and 3 make 21. So you got 21. This one is square unit. You would count, there would be 21 little squares with your halves. You count them together, and you can see right here, these two halves would make 1, these two halves would make 1, and these two halves would make 1, so there's 3. Plus the 18 that you got with the 6 times 3. Okay, the last one. The area of a square field is 625. So once I hear the word square field, I draw myself a square. Okay, because I know the field shape is now a square field. It has an area, so I'm going to put inside area equals 625 square yards. It has an area. So they want us to know how much fence would I need if I was going to fence that area in. If this is the pen that I've got for my pigs or something, then how much fence am I going to need to go around it to keep those pigs inside? Okay, we got to figure that out. So how do I got to start back with my formula. Area equals side squared for a square. What piece did they give us? What piece did they give us? The A, right? So yeah, it's going to be 625 equals S squared. And you're going to square root both sides. So S is how much? 25. So each side is 25. Okay, these are 25, this is 25, so the perimeter, 25 feet times 4 sides. The perimeter is 100 yards. 25 yards, not 4 sides, sorry. So it's 100 yards, not 100 square yards. You would need 100 yards of fence. How many feet of fence would you need? 300, right. There's 3 feet for every yard. So you need 300 feet of fence or 100 yards of fence. All right, that is it for 8-1.